The second series that I'm going to talk is telescoping series. For the telescoping series, is just the series of infinity n equal 1 of one equations minus with the another equations, and equation A and equation B must be related and continuous with each other. So when you see the series of one equations minus with the other equations, then the first thing that you're going to remember is just using telescoping series. Find the series above if it is converge or diverge, and find the values of the series. Series of n equal 1 over n plus 1 with n plus 2. This equation seems not to be the equations using for telescoping series because there is no functions minus with the other functions. However, we can use partial for it. I name 1 over n plus 1 times with n plus 2 equal with a of n plus 1 plus with b over n plus 2. This is partial. A times with n plus 2 plus with b of n plus 1 equal with 1. As n equal with minus 2, a times 0 plus with b times with minus 2 plus 1 equal 1. So that 0 plus with b minus 1 equal with 1. So b equal with minus 1 since you divide both sides by minus 1. As n equal with minus 1, then a times with minus 1 plus 2 plus with b of minus 1 plus 1 equal with 1. So 1a equal with 1. So a equal 1. So that is this equation equal with 1 over n plus 1 minus with n plus 2. Rewrite a series, we have minus with n plus 2. And now this one is telescoping series. S of n equal with the sums of n 1 over n plus 1 minus 1 over n plus 2. So S of n equal with, you just plug the numbers in. As n equal 1, 1 plus 1 minus with 1 plus 2 plus with 1 over 2 plus 2 plus 1 minus with 1 over 2 plus 2 plus with 1 over 3 plus 1 minus with 1 over 3 plus 2 plus with 1 over 4 plus 1 minus with 1 over 4 plus 2 plus with 1 over n plus 1 minus with 1 over n plus 2. So S of n equal with 1 over 2 minus 1 over 3 plus with 1 over 3 minus 1 over 4 plus with 1 over 4 minus 1 over 5 plus with so on more plus with 1 over n plus 1 minus with 1 over n plus 2 minus of 1 over third plus with this one will just keep cancel. So this one will be cancelled by the previous terms, so that we have S of n equal with 1/2 minus with 1 over n plus 2 Then we can use limitations. Limit of n to infinity of s of n equal with limit of n to infinity of 1/2 minus with 1 over n plus 2. This one go to 0 as we take limit. Then this one equal with 1 over 2. For the question B, the series of n to infinity n equal 1, the series of infinity of n equal 1 of L length of n plus 1 over n plus 2. Use the natural log rules of a over b equal with L length of a minus L length of b, so that we have the series of n equal 1 of L length of n plus 1 minus with L length of n plus 2. We're doing the telescoping series again, so we have Sn equal with L length of 2 minus L length of 3 plus with L length of 3 minus with L length of 4 plus so on more plus with L length of n plus 1 minus L length of n plus 2. So we cancel out. So this one cancel with the previous terms. So S of n equal with L length 2 minus with L length of n plus 2. So that we have limit of n goes to infinity of S of n equal with limit of n to infinity of L length 2 minus with L length of n plus 2. Limit of n to infinity of L length of 2 minus with infinity is diverged. For question C, the series of n equal 1 of e to the 1 over n minus with e to the 1 over n plus 1. So S of n equal with e to the 1 over 1 minus with e to the 1/2 plus with e to the 1 over 1/2 minus with e to the 1/3 plus so on more plus with e to the 1 over n minus with e to the 1 over n plus 1. So it left out with S of n equal e minus with e to the 1 over n plus 1. Then we take limit of n to infinity of S of n equal with limit of n to infinity of e to the minus e to the 1 over n plus 1 in the bracket. This one go to 0, so that we have limit of n to infinity of e minus 1, which is e minus 1. This one converged, since it's have the numbers, real number. Quick tip for you guys. So many of you guys gonna confused about like how many terms do you need to do for the telescoping series, since like there's some these kind of questions it just have one terms, one term at the beginnings and one term at the end. But some question they gonna give you like some series like this is the summaries for telescoping series. Step 1, find n values difference between two equations in the series. Step 2, make S of n equal with n terms at the beginning used the equations that has smaller value at start, then plus 1 to that equations. till the n turn for beginnings over. You know that like it have to be plus between positive between the terms. Use the equation that has the bigger value at the end, then minus 1 continuously to reach to the end turn end of the n values. How to find the n values? It is the absolute of the function difference, function a minus with function b. In it's just like, for example, L length of n plus 1 minus with L length of n plus 2 series. You cannot use this one. Absolute like this. You shouldn't do like this. No. The way that you should do is absolute of n plus 1 minus with n plus 2 equal with n plus 1 minus with n minus 2. So absolute, so then we have 1. So that we just have one value different. Time with 2. So that we have two terms. One at the beginning and one at the end. For example, a length of n plus 1 over n plus 5 series infinity of n equal 1. So this one you can differentiate it as series of n plus equal 1 of L length of n plus 1 minus with L length of n plus 5. First step that you check for the n values is just n plus 1 minus with n plus 5. So it equal with n plus 1 minus with n minus 5. By that, this one cancels, so we have absolute of 4 time with 2, so we have 8 terms. 4 in the beginnings and 4 at the end. So that S of n, I use this one at the beginnings term and this one as the end terms. And we know this is 4 terms at the beginnings and 4 terms at the ends. So 4 times 4 times. S of n equal with L length of 1 plus 1. First terms. For the second terms, we just raise it by 1. So 1 plus 1 plus 1. Second terms. The third terms is just L length of 1 plus 1 plus 1 plus 1. And the last terms is the fourth terms is L length of 1 plus 1 plus 1 plus 1 plus 1. This is the fourth terms. And these four terms are beginnings. Now, for the 4 terms end, it is start with the minus use this function first. And now I started backward. And remember, this is minus, this is plus. When you move upward at the beginnings, it's plus, and values inside will be plus 1. When you move it downward, then it's negative, and values inside minus 1. So ln of n plus 1 minus with ln of n plus 5 minus 1 minus with ln of n plus 5 minus 1 minus 1. This is the first terms, second terms, third terms, and the last terms is the fourth term. So minus with ln of n plus 5 minus 1 minus 1 minus 1. So s of n equal with ln of 2 plus with ln of 3 plus with ln of 4 plus with ln of 5 minus with ln of n plus 5 minus with ln of n plus 4 minus with ln of n plus 3 minus with ln of n plus 2. See, this one is just moving upward plus 1 values and positive. And this one is moving downward up, increasing values. This one is down minus 1, negative, and decreasing values. And also for calculating for the terms, maybe it's just gonna be 1 over n plus 1 minus with 1 over n plus 3 series. So we just use this bottom one, this values only. We cannot use the whole equations. Don't use for the whole equations. So absolute of n plus 1 minus with n plus 3 absolute, so that we have this one cancel, so we have 1 minus 3 is 2 times 2 is 4 terms, 2 at the end, which is 4 over divided by 2, and 2 at the beginnings, which is 4 divided by 2. Two term ends always, the terms end and the terms beginnings always equal with their orders. Term n equal with the numbers of terms begins. 1 over n plus 2 minus with 1 over n plus 5. I will realize that this series will have 6 terms, 3 in the beginning and 3 in the end. And here I can show you the magical of math. How can I know that this is 6 terms and 3 in the beginning and 3 in the end? So you can see the values of n plus 2 and n plus 5. It's just different 3 values, right? When you have 3 values, you just times with 2. This one is always stable. The value difference times with 2. The value difference is just like 5 minus 2 equal with 3. 3 is the values of difference. For example, the series of infinity of n plus 1, n equal 1, of 1 over n minus with n over plus 3, for example. Then we can have either it's gonna be 1 minus 3 absolute equal with 2. So there is two values difference. 10 with 2, so we have 4 terms. And this one is 2 at the beginning and 2 at the end. I'm gonna explain to you what is 3 at the beginning and 3 at the end, and 2 at the beginning and 2 at the end. You can see, for examples, for some questions like this one, it's just different than one variable, right? One variable difference. It's in absolute of 1 minus 2 of this one minus this one is just absolute of n plus 1 minus with n plus 2 equal with absolute of n plus 1 minus with n minus 2, which is 1. So you can see one variable at the beginnings and one variable at the end. Go back to the series. N equals 1 of 1 over n plus 2 minus what 1 over n plus 5. I know this one is have 6 variables, 6 terms. 3 in beginnings and 3 in the end. So that S of n gonna be 1 over 1 plus 2 plus with 1 over 2 plus 2. I use this functions only. Plus with 1 over 3 plus 2. So this one is variable first variable. This one is the second variable. This one is the third variable. For this beginnings, I use it upward, so from the beginnings to here. For this kind of functions, for the functions that contain the value smaller, I'm gonna use it for the first terms at the beginnings, and they always plus. You can see right here. Okay. Beginning upward. So we finished with 3 in the beginnings. So now what we do more is 3 in the end. So I begin with 1 over n plus 5, which is this functions right here, this equations, minus with 1 over n plus 5 minus 1, minus with 1 over n plus 5 minus 2, which is S of n equal with 1 over third plus with 1 over fourth plus with 1 over fifth minus with 1 over n plus 3 minus 1 over n minus plus 4 minus 1 over n plus 5. So this one is moving downward. At the end, let's move from this functions down to here. Free variable, free end. Okay, and then I take limit of these things. So limit of n to infinity, you know this one go to 0, this one go to 0, this one go to 0, so just 1/3 plus with 1/4 plus with 1/5 of S of n. So series of n equal 1 of 1 over n plus 2 minus 1 over n plus 5. N S of n equal with 1 over 3 minus 1 over 6 minus a plus with 1 over 4 minus 1 over 7 plus 1 over 5 minus 1 over 8 plus with 1 over 6 minus 1 over 9 plus with 1 over 7 minus with 1 over 10 plus so on more plus with 1 over n minus with 1 over n plus 3 plus with 1 over n plus 1 minus 1 over n plus 4 plus with 1 over n plus 2 minus with 1 over n plus 5, and then we stopped. This terms and this terms gonna cancel by the previous one, so that we have S of n equal 1 over 3 plus 1 over 4 plus 1 over 5 minus 1 over n minus plus 3 minus 1 over n plus 4 minus 1 over n plus 5. See, this is the free terms beginnings, and this is the free terms end. So which we have 6 terms in total. The beginnings always is the plus terms, and the end always be the negative terms. By that I gonna mean so far, it's just like this one is plus for the all beginnings and minus for all the end. Okay, if you don't understand like what I'm explaining, then you can skip the steps, because like it might be really complicated for you then.